All right, class. Welcome back to one of our final videos here as we wrap up this remote learning this year. And in this one, I wanted to take a chance to kind of review a topic from earlier this year that I know students often struggle with initially, and by the time they're in geometry, I see a lot of my students have forgotten how to do this. So I just want to make sure that you're leaving this year knowing how to do this skill so that when you do get into geometry, you can easily use it for some of the work that's done in that class. This topic is simplifying radicals or simplifying radical expressions. And what I mean by a radical is something under a square root. So for example, we can look at the square root of 36, and I think most of us right away know that that square root of 36 is equal to 6. Where it gets a little strange, some of us don't realize that the square root of 36 can also be written as a product of its factors. So I can call this the square root of 9 multiplied by the square root of 4. Because 9 and 4 multiplied to give me 36. They're both under the square root. Truthfully, that's no different than writing it as all under one square root, but separating it might help students see what's going on here. So let's stick with my initial way I wrote it, because now I can see the square root of 9 is 3, the square root of 4 is equal to 2, 3 times 2 is 6. So that's another way to get that same square root of 36. That idea, although not necessary on this problem, is really important because we might run into numbers under a square root that are not perfect squares. Let's take a look at 90, for example. So the square root of 90 is not a perfect square. We aren't going to just guess it. We could use a calculator to get a decimal approximation, but to get it in exact form, we'll want to use this method. So with 90, right away, we want to start thinking, okay, what are some factors of 90? So if I just break 90 up, well, some people might say 9 multiplied by 10, and that's a good one to think of because then we're doing the square root of 9 multiplied by the square root of 10. Simple enough. We get to 3 multiplied by the square root of 10, and that's actually our final answer. We don't even need the dot between it. We just write 3 radical 10 as an exact answer. You'll notice, although I took the square root of 9 to be 3, I didn't do anything to the square root of 10. And that's because I know that the factors of 10 are 2 times 5, and I can't go any further than that. Neither 2 or 5 is a number that has a square root, meaning 10 is kind of stuck. We're at really as low as we need to go. I could write this as 3 times the square root of 2 times 5, but there's no reason to have 2 and 5 in separate factors instead of their product of 10 here. So that's why that wasn't done. Now some of you might be thinking, well wait, you picked 9 times 10 for your factors. What if when you look at the square root of 90, your first thought is, well, that's the same as multiplying 3 times 30. And that's a very fair thing to be thinking about. I'm going to need to jump to the next page. So again, that square root of 90 could be viewed as the square root of 3 multiplied by 30. Well, when I break that up, the square root of 3 multiplied by the square root of 30, 3's kind of stuck. I can't do much with it. 30, however, can keep being simplified. The square root of 3 multiplied by the square root of, well, 30 could be viewed as 3 times 10, and we could separate it. Since I see the square root of 3 times the square root of 3, I can do that math and call it the square root of 9, which has a true square root that's a nice whole number of 3. Or I could also recognize, since 3 is here in both and gives me a pair, that's automatically going to be my square root. The 10, just like before, might as well just hang around how it is, because the only other way to write it would be the square root of 2 times 5, which doesn't help us any. So leaving it as the square root of 10 is a fine way to go about it here. We could even look at this other ways. Maybe someone approached it and they did all of this exactly the same, but then they said, well, the square root of 30, that's like the square root of 6 times 5. And that square root of 3 didn't change. Well, now, square root of 3 times the square root of 6 times the square root of 5, we're multiplying those together. We can't do anything with the first one. 6, however, can be written as 3 times 2, and 5, we can't really do anything with its square root. So now as I break it up, you'll see I still get that pair of square roots of 3 that gives me 3, and that's now multiplied times the square root of 2 multiplied by the square root of 5. Well, 2 and 5, they can't be taken as perfect squares. There's no whole number that can be multiplied by itself to give us those. So I can combine them together and say the square root of 2 times 5. And sure enough, 2 times 5 is 10. We've arrived at that same answer multiple ways, because as long as we go down and we factor until we get perfect squares, we're going to end up with the same final answer. If you go down to something like 3 times 3 times 2 times 5, that's the prime factorization of 90, and it lets us pick out the pairs that we'll use to come up with our 3 on the outside. Let's look at another example. So let's now look at, we could do this with any number. Let's pick 75. The square root of 75 can't be taken. You need a calculator to get a decimal approximation, but you might know that 3 multiplied by 25 is the same as 75. And this gives us an aha moment when I see 25 under a square root. I know I've done something good here, because 25 is a perfect square. So I get the square root of 3 multiplied by 5. The way we'll write this, we'll always have our number outside of the square root on the outside. So like 5 that doesn't have to be under a radical anymore goes in front, and then we'll write the square root of 3. Some of you may have looked at this differently and said the square root of 75 was actually equal to 5 that's not a good 5. 5 multiplied by 15. There's no problem with looking at it this way. We just have to keep going with 15, because it's also 3 multiplied by 5. And now that we've seen that, one last step. Since I see 2 square roots of 5, I know that that could be multiplied to give me the square root of 25, but ultimately just 5 comes out as that square root. So I arrive at the same answer either way. That's another good example to look at. One other thing that we may see would be a variable involved with this as well. So let's pick another value. Let's do the square root of, let's to keep it simple, use 75 again. But now let's call it 75x cubed. All right, so this should look pretty comfortable because we just worked with 75, so I can write this as a square root of 3 multiplied by 25 multiplied by x cubed. Well, I handle the 3 and the 25 the same way. And we can also put x cubed under a square root like that. Well, I know 25 gives me 5, so it'll be 5 times the square root of 3. But now I have this square root of x cubed hanging around still. Well, when I think of factors of x cubed, it's actually easy to think of it as x multiplied by x multiplied by x. But wait, it could also be written x multiplied by x squared. When I see x squared, I know I have a perfect square now. So this can continue to be written as square root of x multiplied by the square root of x squared. The square root of anything squared cancels itself out, so that's just x times the square root of x. When I combine that with the 5 times the square root of 3 that I already had, it looks like that. That's pretty funny to write it in this order. Let's combine the values or terms outside of the square root with the parts that are under the square root. So we'll have 5x radical 3x. And that's how we would work with that in a situation where a variable shows up. So this was kind of a review. I know we looked at this earlier in the year, but I'm also willing to bet that a lot of you guys needed this refresher to really feel confident with this. Use this video to help you through the worksheet attached on Google Classroom, and let me know if you have any questions along the way. All right, good luck, class.